Welcome to this webinar, the third webinar of the webinar series of SG France 2021. So this webinar will be focused on the future of the International Space Station, and we will wonder about the different way of diversification of the ISS activities from 2025 to 2030 to create opportunities for non-space sectors to welcome new opportunities. So to wait for the people who will arrive, I propose you an interactive activity in order to better know you, to know where are you from. And this activity will be done on Slido. So Guillaume, can you write down in the chat the link to Slido in order to people to join it?
Yeah, sure. Should be done now.
Okay, great. So you can click on the link in the chat, in the Zoom chat to join the Slido. Normally you can see it on my screen. So the first question for you who are here is, where are you from? A very diverse audience. This is great. I move on to the next question. To how many SJC events have you participated before joining this one? So we have a lot of newbies and some of aficionados of SJC events. Great. So I move on to the next question. In what sector are you studying or working? Just to know what are your expertise for this webinar. You can be precise. Arts, okay, great. Great. Commercial space stations, aerospace medicine, engineering, human space flights, telecom, okay, interesting topic. Aeronautics and robotics, very interesting too. Venus sample return, oh, software dev, master in astrophysics, trying to change to the space sector. Oh, we have someone who tried to find some opportunities here. Great. Final question, to know if there are people who will be coming to Lille. This subject concerns everyone, so it will be great. Okay, I think we are done with Slido. I'm going back to, so for to begin this webinar, we'll have a presentation by Tanya, the event manager of SG France 2021, about SJC and the event. Tanya, the floor is yours.
Can you hear me well? I'm sorry, maybe
yes.
Here. Thank you, Charles. So hi everybody, I'm Tanya. I'm the event manager of SG France 2021, which will take place in 2 weeks now, and we really can't wait to host you in Lille on the 3rd of July. So I'm going to talk to you a bit more about SGAC and SGAC in France, especially. So SGAC is basically, yes, as you can read, a non-governmental, non-profit organization. So it's a big network of students and young professionals all around the world that love space. So we have today a very growing community of more than 15,000 members worldwide. So it's a very great opportunity to have scholarships and have many benefits from the space sector. Yes, next slide, please. I'm going to talk to you more about the activities that we can have at SGAC. So you can have many events organized all around the world. So it can be different scales or global events like the SGC, which is taking place at the same place as the IAC each year. But you can also have some more local events like SG France, for example, or SG Germany, or in each countries you can have some events that will be hosting people from the country or a bit around. So when you don't want to participate to some events, but you prefer working on a very hands-on experience in the space field, you can work on some different project groups. They can go from space exploration to space law, space medicine, and different space topics. So you can find them on the website of SGAC. You can also have develop your professional experience and have a growing network around you and meet people at those events or those project groups. And you can get some scholarships as well from SGAC to attend some space courses, space university, and experience and events like this as well. And finally, you have some United Nations related activities. As the main goal of SGAC is to provide the voice of young generation and students in the space field. And it's basically the opinion of the young generation in space and what we think about, and we go and talk about it to the United Nations each year. So now I'm going to talk more about SGAC in France. So this is also a growing community that we have of more than 230 people all around the country. We have two fantastic national point of contacts. You have one here, which is Guillaume. And we have a WhatsApp group where we can share many opportunities and the events also happening each year. So last year we had SG France 2020, and this year we have the SG France 2021, tackling the subject that I'm going to talk to you more in detail on the next slide. So yes, SG France 2021 is the third SG France organized. So it will be happening in Lille on the 3rd of July, and it will tackle the subject of how we can bring more space in our daily life and how we can find more synergies between space and non-space sector, and more collaboration and innovative collaboration. So through 4 different topics that are on your right, we will try to find how to bring more space in our daily life. So we had already 2 webinars, and today is the 3rd webinar that we are organizing, tackling the subject of our 3rd roundtable. But we're going to talk about it more in detail now. And next week we're going to have the webinar of Antoine tackling the lunar exploration topic. So next slide is going to talk to you about the events that are happening close in terms of distance and also in terms of time to our event. So we have the SpaceCon, which is starting tomorrow, actually, on the 19th of June, with a Kerbal Space Program contest. So it's going to be a very cool event. So tomorrow is a game contest, but on next week it's going to be more like a formal event where you will have the opportunity to talk with their sponsors and the people coming there. You will have some inspirational talks and experts coming on the D-Day, and you will have a pitch contest to present your project or your idea in front of a jury, and you can win some cash prize, which is very interesting. You also have the Summer Space Festival taking place on the day after SG France 2021. So it's another opportunity to come to SG France in Lille, which is a bit far away from the center of France. But it's also great to go there because there are going to be other experts and other good people from the space sector talking about their passion and everything they are working on in this moment. So don't hesitate to visit their webpage that are here, and maybe in the chat if Guillaume would like to share them. But yes, we invite you to attend those events as well. So now I think I'm over with my presentation, and let Charles talk about the topic of today.
Thank you very much, Tanya, for your presentation of all the activities performed in SGAC. So the topic of today is the future of the International Space Station. The International Space Station is one of the greatest international projects of all time. And it's an orbital space station orbiting around Earth at 400 kilometers from ground, and including 5 different space agencies, which are NASA, ESA, JAXA, Roscosmos, CSA. And last year, the 20th anniversary of the International Space Station was celebrated. So 20 years of ongoing human presence in space, 20 years of scientific research in a very unique microgravity environment, and 20 years of acquired experience for future space exploration. So its future is depending on its investors, the future of the ISS. The major contributor currently is NASA, but due to new ambitions, things will certainly change. And the focus of this webinar is on how to diversify the ISS activities to create opportunities for non-space sectors from 2025-2030. So we are really pleased to welcome 3 speakers. So the topics that will be discussed will be science and technology, space tourism, and art and culture. And our 3 speakers today are Jason Aspiotis, who is a business development manager at Axiom Space, who has a total experience of 18 years in the space industry, in entrepreneurial, R&D, system engineering, and is an alumnus of SGAC. So he will talk about the ISS, its environment, and space accessibility for different kind of businesses, industries. Then Lucy Campagnolo is project manager at MEDES, the Institute for Space Medicine and Physiology, sorry. And moreover, she is head of healthcare applications in CNES to promote and foster innovation between the healthcare and space industrial sectors. She will talk about commercial opportunities, but specifically on the life science domain. And finally, we have Annick Bureau, who is an independent art critic, curator of art, and specialized in technosciences. She organized a lot of symposia about parabolic flights, about extreme environments, about microgravity. And she is also a member of the IAF Technical Committee for the Cultural Utilization for Space, and she's the director of Leonardo Olatz. She will talk about the old relation between art and space, and she will also consider the artistic potential of the ISS. So the first speech is for Jason. Jason, the floor is yours. You can share your screen.
Thank you, sir. Happy to be here. Yeah, let me share my screen really quick and we'll get started. All right. Can you see what I see?
Yes, we can.
Great. Yeah. Thanks for being here. And a very important topic on the ISS, what it's done for the industry and where it's going in the context of the next 10 years and beyond. So as Charles mentioned, Jason Aspiotis, BD manager here at Axiom Space. And for those of you that don't know, Axiom Space, we're building the world's first commercial space station. And I'll talk a little bit about that towards the end of the presentation. So the themes I want to talk about today are 3. And the first one is, ISS legacy as a humanities orbital, laboratory and stepping stone towards LEO commercialization. And then I'll flow that into, what do we mean by LEO accessibility and actually how NASA contributed to enhancing LEO accessibility and what more we could do as a collective in the industry to continue to grow accessibility to low Earth orbit, because ultimately, when you talk about developing a LEO ecosystem, you need to keep reducing launch costs. Launch costs drive all of your economic considerations for what's viable in low Earth orbit. And then finally, I'll talk about commercial space stations and new markets, and a little bit of what Axiom is doing in this particular sector of the space industry. So a lot of information on this slide, but I just want to highlight that the ISS has done a lot and has a lot in terms of facilities to facilitate multi-purpose research development. So these resources are available for you all to go click and just go study what the ISS has today. And these are just some examples of the things that they have and do as far as research in materials, biotech, physical sciences, micro-G simulation, and other very interesting fundamental science areas. So again, the point here is the ISS was established truly to spearhead and seed fundamental research in these categories in the hopes to find those intersections where there's viable new science in terms of gravity that leads to new discoveries, but also potentially new products that could benefit humans back on Earth, but also humans and in space. So a little bit of context about operating the ISS, right? So the ISS, as Charles mentioned, is mostly supported by NASA. And there's been 37 commercial resupply missions since 2012. That's about 3 to 4 per year. NASA puts in about $1.5 billion to support its operations and maintenance, about $1.8 billion for transportation of crew and cargo to from ISS, and then about $50 million, not so much, but $50 million to support the ISS national labs. These are the funds that go to enable research payloads to be sent and integrated the ISS. And the bottom line I'm trying to portray here is that it's a very, very heavily subsidized piece of infrastructure from a government perspective. And that's just the way it has been and continues to be. And here I wanted to highlight sort of, you go back to 2012 when commercial resupply started, and kind of paint the picture of all the types of users of the ISS. So you got academia, which is universities and schools, civil, which is NASA, DoD, which is Department of Defense. Then you got a bunch of different other categories, large companies, nonprofits. SME means small to medium-sized enterprise or company and startups. And what we believe is very encouraging out of all this, because you see most of these users have been relatively steady the past 9 years. Startups and small companies have actually started to pick up. And that's very encouraging, because that's typically where innovation, new products, new applications are being developed at startups and small to medium-sized companies. So seeing that right before COVID hit was a very encouraging trend, and looking forward to seeing more 2021 shows in terms of hopefully continuing this trend of startups doing good work on the ISS. Now let's hop over to accessibility. And what we mean by accessibility is how easy, how reliable, and how expensive it is to get to low Earth orbit. And in the 90s and 2000s, it was all about government launch systems. And we had the space shuttle, and we have Soyuz. They were the primary transportation modes to get humans and cargo and supplies and systems to the ISS. And then NASA figured out, we need to stimulate commercial capabilities, because we think if commercial and enterprises take on this piece of the puzzle, they'll be able to theoretically do it cheaper. So the NASA COTS program was invented back in the mid-2000s. And out of that emerged essentially SpaceX. So between the 2000s and where we are today, if you look at the data available, launch costs for SpaceX specifically come down at least 10x. So NASA made a good bet that by stimulating commercial competition for the transportation piece of the equation, they would increase the availability, the repeatability, but also reduce the costs of transporting things to the ISS and low Earth orbit. And that's where we are today. And this is actually a study I did a few years ago with a colleague. And what we're trying to show is exactly that. As a function of time, as SpaceX and other transportation modes that use liquid hydrogen, liquid oxygen, the more you do these types of systems and launches, the better they become in terms of commoditizing the equipment and the processes and procedures to actually facilitate launch, meaning the more you do it, the cheaper it becomes. So in the case of SpaceX, you see a steady decline in the price, a function of how many times they launch rockets. The same thing goes for ULA and others. And that's a very encouraging trend, and it makes sense. It should be common sense. The more you do something, the more you produce something, the better are your processes and machines to make that something. Therefore, it becomes cheaper. And so when you look at stimulating new markets in low Earth orbit, new markets, new products, etc., you got to think about what is the economic viability of the thing you're trying to create. So let's take a biotech product. Arbitrarily say it's something to do with fixing eye vision, for example. If that product made in space is 2 times better than what it's made on Earth, but at the same time it's 100 times more expensive, who's going to buy it? So economic viability of products made in space ties in directly to the transportation costs, because those are the primary drivers of cost for anything to be made in space. So what I'm showing here is that today, yeah, there's aspirational markets out there, but really the only entities that can afford to go to space are governments, DoD, and PAMs, so private astronauts missions. So that's the term we use here at Axiom to describe quote unquote tourists, but they're not tourists. They are private/professional astronauts that want to pay to go do research development in space. Now, as you go forward in time and you believe the trend of the more you launch stuff, the more things you do in space, costs come down, then is it possible that biotech products and the advanced materials manufacturing type products start becoming economically viable? And the answer is most likely yes. And further as you go in time, does space tourism for the masses become economically viable? And the answer is probably yes. But again, it all goes back to how expensive transportation is. And systemically speaking, we have to address that to open up these further elastic demand markets. So what are the markets today? And legacy, we got government, ISS, we got Earth observation and LEO, communications, GPS, and military assets. And actually GPS is MEO, not LEO, but close enough. And then we got emerging markets. We got private astronaut missions, as I described. We got LEO broadband from SpaceX, Starlink. We got emerging other constellations, both in the US and around the world. And we got space debris remediation. So we have some demos and some movement in developing capabilities to address the space debris problem. Now you look in the future, maybe 5 years from now, what starts to occur. So I switched the legacy ISS to commercial space stations because the ISS is on track to be retired by 2030, right? So in this new world, 10 years from now, commercial space stations will be facilitating the types of services and operations the ISS has been doing, but doing a lot more. So the legacy markets will remain. Established markets now will be private astronaut missions, LEO broadband, space debris remediation. And then think about blue ocean markets, the things that a lot of us aspire to develop, but will require some additional R&D, prototyping, and eventually some time to operationalize them and make them profitable. So orbital services, assembly manufacturing is one of them, OSAM. Think about commodities exchange, so bringing up fuel or other commodities in low Earth orbit and beyond and exchanging that between entities, whether it's business to government or business to business. And then you got manufacturing of goods, and I've coined the term space to Earth for goods made in space to be brought back to Earth. And then goods, space to space goods, which from the name implies goods made in space to be used in space. And of course, tourism and orbital industrial parks, and our long-term vision as a company, which is cities in space. So having thousands of people living and working in Earth's orbit, hopefully in not too distant future. So what is the case for commercial LEO stations? And the way I want to frame this is, what are the really differences between ISS, a government-owned and operated station, and a commercial space station, which is privately owned and privately operated? And the one comparison criteria as well with government, and as I mentioned, for the ISS, government is owner and operator, whereas for the commercial space station, the government is just one of many customers. And as far as the charter, right? So ISS was established to facilitate fundamental or basic R&D and eventually help seed the LEO growth, the LEO economy. Commercial space stations, by definition, to get invested in and get funded to go build the station, you have to go beyond that. So we're looking at applied R&D. So taking what we've learned for fundamental R&D and applying it to specific applications and development of specific products for specific markets. And eventually, not just seed, but accelerate growth of a commercial LEO economy. which ties into the last category, revenue generation, right? So what are the economic transactions? And right now, you don't really have revenue transactions other than private astronauts paying for a ticket to go to the ISS and stay there for a few days. And that's really the only commercial transaction. But in the future, you could look at transactions between government to businesses, business to consumer, business to business, or even business to business to consumer. So you're opening up really the spectrum of revenue generation and economic transactions that can occur. And the one I missed, CapEx, capital expenditure. So who actually funds the build-up of these stations? So for the ISS, we all know is government. And for commercial space stations, it has to be either private, equity and debt, reinvestment of profits from the private entity or entities, or even the public markets. So you're seeing a plethora of companies here in the US going public through the SPAC mechanism, the special purpose acquisition company mechanism, which makes those companies publicly traded. So that's another method to fund the development of space stations. So some context of where we are, and right now we're supporting the ISS. So we're sending astronauts, private astronauts, we're sending research and development payloads to the ISS, and that will continue for the next 3 years. And then in 2024, we send our first module to the ISS. So we become part of the ISS, but it will be the world's first commercially owned and operated module in LEO. And then we'll have 3 more modules every year thereafter. In 2028, we'll have the world's first free-flying space station. So we'll detach from the ISS and commence operations as our own free-flying space station. And I won't go through all of these, but this is just an idea of all the things that we believe we can do and we can offer as part of the commercial space station. So, far left, we've got all the customers, so governments, private astronauts, researchers, media is an interesting one. Services, it could be human-centric services, could be laboratory and research type services, but it's also other types of services like on-orbit data services and cybersecurity that then lead to all the way on the right emerging markets that some of them we have an idea of what they can be, but there may be some unknowns that we will figure out as part of the process. And so when it comes to on-orbit manufacturing for space to Earth, the 7 categories that we sort of done a bunch of fundamental research thus far and base demonstrations. These are products that could have a potential product market fit in the next 10 years, assuming launch costs keep coming down. There's also the unknowns. So there could be new research on the ISS the next 5 years that lead to new discoveries, that lead to new product development cycles and new markets that we just don't know yet. But the point here is, the ISS has been very successful in extracting paths for new products and new services that otherwise we had no idea existed. So the ISS was successful in its original mission. And, on-orbit manufacturing for space is space, which I think is also a very, very interesting part of the industry we're trying to build in the low Earth orbit ecosystem. Because scale, when we talk about economic growth, you're talking about scale, and scale requires infrastructure. And building infrastructure in space makes sense because you're no longer beholden to the limitations of launch. Because launch is not just about cost, it's also about size. Even if launch costs come down to economically viable levels, you still need the ability to build large infrastructure, large structures in space to facilitate further economic transactions and economic growth. So these are just examples of all the things you can make in space that make sense to make in space, to then use in space as part of your larger commercial infrastructure strategy. And that's it. I hope this was helpful in sort of painting a picture of how the ISS enabled the humanity to reach this point. And now we live in a very, very exciting time where commercial space stations will help push the LEO ecosystem towards broad economic development for the entire world. So thank you for your time. I look forward to any questions.
Okay, thank you very much, Jason, for this very interesting presentation about the future Atom space station, commercial space stations. So I didn't mention it before the presentation, but you can ask any question in the chat. Our team will gather them in the file, and we will have a Q&A session at the end of all the presentations to ask the questions. So do not hesitate, write down any question. So now we are going to hear about your presentation, Lucy. So as I said in the introduction, you can share your screen.
Yes.
As I said in introduction, you are going to talk about commercial opportunities, but specifically to life science domain.
Yes, thank you. Thank you very much, Charles, for the invitation. Oh, sorry. Excuse me 1 second. Here, do you see my screen? Is it fine?
Yes, it's perfect.
Yes, okay, thank you very much. So my name is Lucy Campagnolo. I work for MEDES, which is the Institute for Space Medicine and Physiology, and I will explain a little bit later on what it is. But I just want to mention that my colleague Clara is also joining this webinar. She's an AGAC member and she works in the same team as me. So we will be 2 people able to answer your question. And as Jason said, and thank you very much, Jason, for your presentation, we are going to talk about applied science, so commercial science in low Earth orbit, and in particular, life science and biotechnology and biomanufacturing. So MEDES, as I said, it's located in Toulouse in France, but we operate on a European level. And we are a hybrid organization between space and health. We are an economic group of interest, and our 2 main members are the French Space Agency and Toulouse Hospital, but several other universities and hospitals are also part of the board. And we have 3 main missions. We provide operational support for everything related to space medicine and physiology in low Earth orbit. So in particular, support for experiments. And also we provide all the space crew surgeon for European astronauts, not all, but a huge part of the team, and also medical follow-up for emerging space agencies that want to have a new astronaut or private tourism. We also operate a clinical research infrastructure. It's located in Toulouse, where we conduct some clinical trials to mimic microgravity on Earth. So it's called the bed rest study. So people are lying down for a certain time, and we have lots of scientific protocol in order to study the response of the body of this unusual position. And then Clara and myself are working the application and innovation team, where we try to really foster innovation, and we have a much more commercial aspect by bridging the 2 domains that are space and life science. As Jason mentioned, the International Space Station is well known to be a kind of laboratory in microgravity to conduct lots of activity, but in particular, fundamental research. And this is still one of the main activities that is performed by the astronauts right now. But there is currently an opening of the International Space Station, but also other platforms that are existing in low Earth orbit for other kind of activity. So we talk about it. The first one is, of course, new science and innovation, but was a commercial point of view. So applied science, in order to either discover new assets to be used on Earth or to have higher quality R&D or product manufactured good for terrestrial application, and maybe in the future also for space exploration needs. What we see a lot is that there is more and more players that want to use the International Space Station for commercial opportunity in order to open a new market line. So we see this emergence of the economic ecosystem of low Earth orbit, even though it's still highly supported by public institution and space agency. But we see more and more companies, and especially startup and SMEs, that are in this business segment and attract some private investment and private funding to deploy new services in low Earth orbit. And then, last but not least, we cannot neglect the fact of space being a marketing and a kind of branding asset for lots of activity and companies. And this also fosters lots of activity that are more visible and help to attract some new investor and non-traditional space player in low Earth orbit. So when we talk about commercial application, you need to be able to define what's the return of investment for this kind of company, because we are working in the field of life science, in particular biotechnology, and most of these companies, they haven't thought about space as a possible R&D line or application. And so if you just say, okay, you're going to be able to perform some cool research in space, it's not enough for this kind of company to invest, or to be more precise, to co-invest, because right now there are lots of public programs that is able to provide co-funding. So of course, the main pillar right now, it's still innovation and science. We try to advocate that doing experiment in space can really foster new innovation, of course, increase the number of published papers, citation, and overall visibility of the company on the scientific level, increase the number of patents, that is usually a key indicator, and can attract also very good engineer or very good scientist or business developer, because it's unusual. So this has value. But you cannot market that, so do market stimulation program without talking about the economic part of the balance. So like, would your applied R&D in space create new job on Earth? And this is a question that has to be asked. How are you going to turn this activity into a new revenue line? Is it going to accelerate the time to market for your product? Is it going in the long term to reduce some cost or provide some cost saving? This is complicated to evaluate, but the company will invest their own money, and the biotech company, even if we are able to answer this critical question. Another part that is more and more important is the fact that space is still seen and it's still important for to be used for humankind benefit. So some companies are attracted also with the fact that they can contribute to something that is higher than them, just them. So it has a part of branding and marketing, of course, but still with the, for example, corporate social fund, I don't know what the perfect word in English, but the fact that a company redirect a certain amount of money for sustainable activity or climate change fighting activity and so on. So we have to find the whole balance between all this topic in order to attract commercial clients for the International Space Station, and as Jason said, also for the next commercial spacecrafts. And this is still under discussion, especially in the European context. So I won't spend too much time on this slide, but for life science, what is attractive in terms of assets or unique assets that you cannot replicate on Earth? It's of course microgravity, because it affects lots of phenomenon in physical and life science. And on a second level, some people, and especially in cancer research, are attracted to the extreme conditions that can be found in LEO, especially the high energy radiation impact that are complicated to replicate on Earth. So it was mentioned in the talk before, but in terms of product or idea, what kind of activity can be conducted? First of all, it has to be understood that crystallization is quite different under microgravity. And even though crystals take a little bit longer to grow, the structures are much bigger and they are much stable and much ordered. And there are some specific instruments on board International Space Station that are specifically dedicated to crystallization. And we see lots of commercial activities that are looking to new targets for disease, new drug development, drug formulation, and so on. We have also lots of activity in cell biology, especially because microgravity and all the stressor of the spacecraft environment affects the cell behavior, the cell fitness, the gene expression, and it also has an effect on the structure, cell structure. Usually, if you want to replicate something like a human bone or something, you need to have a scaffold. Because on Earth you have gravity, so the cells are growing on a two-dimensional level. And on the International Space Station, you can really have complex structure, and it allows to study, to understand the fine mechanism at an organ level. In terms of microorganisms, I'm talking about bacteria and fungi. Space has also a great interest, especially in studying the virulence of the bacteria. That is modified under spaceflight condition. It's still a topic that is not mature, but we see some proteins that are secreted by, for example, E. coli, which is a well-known bacteria, that are different under microgravity. Biofilm is this very invasive and sticky group of bacteria, has also different form and more resistance. So this can also help design countermeasures that can be applied on Earth. We know that microgravity is an accelerated model for aging, especially related to bone and muscle, but also metabolism and cell. So we can have lab on chip and make like fake old people, in vitro fake old people on board in order to test some specific drug or specific formulation to prevent age-related disorder. Another topic that is quite trending, it's plant science. So we are a little bit more far away from the life science topic, but still we know that in biomanufacturing, for example, it's the fact to create bioproduct from a biological source, and plants and bacteria together can create new active molecules that can be then used on the biomanufacturing production line on Earth, and this can lead to the discovery of new active drugs. I will go very quickly here because it's quite similar to crystallization, but we know also that materials are affected by microgravity, especially the one that has a very geometrical structure. And what's quite important, and we see lots and lots of projects on this topic, is the fact that all the phase transfer between liquid and gaseous, all the phase transition, transport and modeling coefficient are different. And this is quite important to feed a mathematical model in order to improve the efficiency of, for example, bioproduction line on Earth. Same thing for fluid dynamics and lab on chip. We have different behavior regarding flow and diffusion and surface tension. And chemistry can also be influenced by the lack of gravitational forces. This has lots of application, for example, in cosmetic, because we tend to discover new way to do more efficient formulation and more stable formulation with longer shelf life. So I've selected an example of projects that has been applied research that has been performed by industrial company in the International Space Station. Most of them are American because, as Jason mentioned, there is the ISS lab that is in place since several years right now, and it really had done this market stimulation program to attract new customers. The first one that I would like to present you is crystallization from Merck, the big pharmaceutical company, and they had a kind of drug called Keytruda for immunotherapy, and it's a kind of large molecule on a crystal form. And what they have seen on the International Space Station, that is possible under certain conditions to grow much larger and concentrated crystal, and therefore to create highly concentrated drugs, because the administration means for this drug it's to be intravenous and it's during several hours, meaning that the person has to be at the hospital for several hours waiting for the drug to come in the body. And to be able to perform to have much more concentrated molecules, it would allow to do like very few injections, and it will be much more nice, first of all, for the patient, but it will cost less for the hospital because they will have to keep the patient for a smaller time. So this is quite an impressive project. AstraZeneca has been under the news lately for all this pandemic situation. They are looking to increase the stability of one of their monoclonal antibody. Why is that? It's because their formulation right now, it requires very stringent condition to remain stable. And especially time has a large effect on their shelf life, meaning that if you have to send your drug to a remote area, first of all, you need a packaging and you have to be very fast. So this requires a lot of additional constraint in terms of logistic, and that costs a lot. And it will make you lose some markets because your drug is not fit for certain area. So this is how you can transfer what has been done on board on Earth in order to first improve the life of the people, because they will have access to this drug if the formulation stability time is longer, but also to decrease your cost because your logistic will be much more simpler and you will reach new markets. Another project, this one is a fundamental project, but I think it's really turning into something commercial. It's called the Immuno2, and it's looking at the effects in gene expression resulting on the immune cells. And we know that astronauts are deficient in terms of immunology. And to study that, it will help discover new curing or new countermeasure for people on Earth that has an immune defect. And this is really important. Another project, very briefly, it's about Parkinson disease, and has been developed by the Michael J. Fox Foundation, the name of the actor that has this disease. And they had lots of difficulty on Earth to crystallize a certain protein that is called LRRK2. And they believe it's involved in the progression of the Parkinson disease. But in order to confirm that and to study this protein, you have to produce it in a lab. And due to the gravity, it's a large protein. It was super complicated to have something stable. So they were able to produce it on the International Space Station to study there, and then to come back with the results. What is important to mention, and it's written in the slide, is that they have to perform 2 flights because the first time it did not grow large enough to be able to be studied. So we still have room for improvement in this activity. There is still a need to invest in dedicated and specialized instruments for life science in order to also decrease the risk of having failed experiment, because it costs a lot. Finally, I think it's one of the last example about cell culture that has been promoted by the National Cancer Institute. And the idea was to create micro-organs, so organ on a chip, to use them as some model, in vitro modeling, to test some drug in microgravity, and especially drugs against age-related disease, because you have a fake organ that will age very quickly. On Earth, it will take much more time. So you gain time, so you increase your access to market time. And another activity that is currently trending in the applied R&D is the use of microgravity to get insight into stem cell activity. There have been some projects regarding cardiac stem cells because the stem cells are tends to retain their stemness in microgravity, so you can do much more research there. So the question is where to start with all that. We on the European level, we have been selected to be the guide of a European company that wants to do this kind of applied research. And by the guide, it means explain what is doable and what is not doable, explain how much it costs, do the kind of a broker between all the commercial providers that can help access to space, but also make sure that the project will be able to fly and provide the result, and this result will be turned into key performance indicator for the company. And this is not a tricky question. So we are here to stimulate the market, to help actors to access to this new opportunity, because as it was mentioned previously, we also believe that in 5 to 10 years, there will be such a decrease in terms of flight costs and operation costs in low Earth orbit that it will become economically viable, and that the support from public institutions won't be as necessary as right now. So yeah, here are our contacts. Do not hesitate to contact us. I hope it was clear. I'm sorry if I took more time than expected. Thank you.
Thank you very much, Lucy, for this very complete presentation. So now it's time for the last presentation by Annick Bureau. So on a totally different subject, we won't talk about business opportunities this time, but we will talk about art and art's relation with space and art's relation with the International Space Station. The floor is yours, Annick. We can see our, yes,
sorry.
We can see your presentation. Great.
Yeah, so you have my screen, right? The slide. Okay.
Yes, we
well, so good evening, everyone, on this Friday evening, and welcome to this thread about artistic expression in the International Space Station. So I have divided this my presentation in two, one for today, one for July. And today I will present a few examples of what has been done before or up to now in space-related art and in art in the ISS. And I will try to point some of the questions that you might be discussing in July. The topic of this meeting is how to open opportunities for non-space sectors in the ISS. Well, speaking from my side of the fence, I wonder what exactly is a space sector when dealing with activities in the ISS, what is considered to be in and what is considered to be out. Beyond, of course, the launch, the building of the station itself, the logistic and the maintenance of the equipment of a building, should I say. But today, let's focus on how art and space is actually a very old companionship. Well, it all started with astronomy and the representation and understanding of a night sky. Then astronautics came into being in the middle of the 20th century. But beyond the mere representations or illustrations of space conquest, and mind you, there has been really a lot of paintings and illustration. With astronautics came the dream of doing art in space with different approaches, such as by creating artistic satellite. And here you have in the 1980s, there were a lot of projects by artists to create artistic satellite. Here you have the American Richard Clark and Arthur Wood's project, here the French Jean-Marc Philippe and Pierre Comte. None of those projects were achieved, but it's interesting to note that this is an inflatable structure, and this is a solar sail, so which was quite cutting edge at that time. But it eventually became possible to create artistic satellite and to launch them. This is one of the example. It started in 2000, in beginning of 2000 years. And it's interesting that the projects that actually were achieved were the ones being CubeSat, so which is much easier than to organize the previous ones. Another approach was to put Earth on another celestial body, of course. And of course, the Moon and Mars were major desirable targets. So it's not only for the scientists, it's also for the artists. And this work, the Moon Museum, was actually, it already actually started very early with the Apollo missions. And this one was done in '69. And it's a small microchip. This is 2.5 centimeters, and this is 1.5 centimeter, with 6 artworks by very famous contemporary artists. I mean, Andy Warhol, Rauschenberg, those are people that are extremely famous in the art world. Another approach is, I don't know, do you see the top of this, or just my screen?
We see the slide. I think we see normally the slide.
Okay, beyond this is supposed to have been attached to the LEM of the Apollo 12 mission, which is still not fully certain, but I believe it was so. Another approach to art in space is, of course, linked to the dream of weightlessness, and with this very famous picture of Yves Klein, Le Saut dans le Vide. And it gave birth to an incredibly large number of artworks, mostly done in parabolic flight in the various training planes. The French choreographer Ketsu Dubois is the artist that since 1990 has experimented the most in microgravity in the planes, the parabolic flight planes. What is interesting, and this is a key point in Ketsu Dubois' work, is that what she's trying to do is to embody the experience of weightlessness on Earth in the body of her performers, so that through the kinetic empathy, she can share what this experience is with an audience on Earth, which obviously has zero idea of how it feels like. On the opposite point of view, there is the research of a Spanish artist, Marceli Antunes Roca, who flew in the Russian plane. And Marceli did not try to embody the experience of weightlessness on stage, but to propose through this robotic exoskeleton, which has pre-recorded movement to bring gravity and the memory of a grounded body into weightlessness. So, space stations and space vehicles. So in between a mobile home and a secondary home, we could say, the stations and the shuttle open new opportunities to deploy what I call the what if question. And those questions and those questions here are key to try to think about art in the ISS, or what living in space does to art and culture, the same as what it does to science, right? What is the role of art in space for humans in space? And this is in between keeping the memory of terrestrial cultures and seeding new civilizations. What is the role of art in space for humans that remain on Earth, between being a witness and having a mirror? Is there an emergence of a space culture? And if so, what is it, or what should it be? And what kinds of new art forms can emerge? So now I would like to show you some examples of artworks that have been creating in the space stations. And I meant space shuttle too, but I'm not showing the space shuttle one. So artists are investigating known art forms to push them further in those what if questions, be they painting or sculpture. Here, 2 sculptures. What happens to sculpture when it's freed from its pedestal and specific point of view or point of perception? And here you have Cosmic Dancer by Arthur Woods, which was launched to the Mir space station. There is Prisma by Pierre Comte, who went to the ISS, and they are both very colorful. This one is fully articulated. It moves, all those things have our axis, so it moves in many ways. Both cannot stand on Earth. They cannot be put on a pedestal. They can be put in something. And both are created for the astronauts to play with, to enjoy, to have fun. And this is also something important. They are dedicated to the population of the space station. The Japanese artist Takuro Osaka worked on a kinetic light object. This is this thing that when it's sent through the station, and this is in the Kibo Japanese section of a station. So what is interesting here is Takuro Osaka worked on this light object, building on the Japanese tradition of artworks related to light, but of course pushing it further. Well, of course, several astronauts, I don't know if we have mosquito in the station, I mean free floating. Several astronauts have brought musical instruments to the stations and played with them. And we know this, right? Here is a musical instrument designed by artist Ayako Ono that was also sent to the ISS. Now I would like to open to what I call societal art. And I call the next works I'm going to show societal, although it is not a real art genre, but because those works are either reflecting on bringing into space something deeply rooted in a specific human culture. The Japanese one, the French, or whatever. Or they are reflecting on very important current issues that we are all confronted to. And or they are experimenting new art terrains that do not belong to the canonical art forms. And it's interesting that the 2 previous speakers talk about bioscience, because there are a lot, and I'll show one in July, there are a lot of bioscience projects currently done in art on Earth, and some done for the, or projected for the station. Major component defining human civilization and culture is the garden, and especially the Japanese garden. And here in Jewish Forest, this is a garden designed by Japanese artist Shiro Matsui for the International Space Station, also deployed in the Kibo module. And this work has really several levels, but the one I want to focus upon is that it is really raising the question of how humans are going to space, what they need beyond the basic life support system. We are not individual beings, we are collective ones, but not only humans, together with our bacteria, and they were mentioned before, but also together with other creatures we need to share the world with in order to survive both physically, but also culturally. And this piece has other component on Earth, and I'm not showing here. Which and those body is going to space. The archetype is also the male hero, right? But beyond that, will we need modified bodies? Here, Adriana Knuth, who is a trans woman, symbolically sent her hormone replacement medications. And it's also echoing the previous presentation in a way. It was done with a collective program conducted by the MIT Media Lab, a space exploration program. It was done in 2020 through the Dragon, with the Dragon. And my last example for today is a work which is very dear to my heart, which is Telescope Intérieur, in a Telescope by Eduardo Cac. And it's about poetry, poetry being also one of the bases of human culture and art. Poetry that can be spoken, that can be written, that can be performed, and here that can also become sculpture. Here, I would like to stress upon the fact that this artwork has been achieved with extremely low-tech material which was already in the ISS, that is 2 pieces of paper and a pair of scissors. And those pieces of paper become both the medium and the message. And it has been performed by Thomas Pesquet in his previous flight. So those quick examples show that space-related art have spanned the trajectory from astronomy to astronautic, and nowadays to space science. And that art has evolved in relation to our evolution and habitat, both in space and on Earth, or should I say both on Earth and in space. And that art is an evolving field in itself. And there is a whole field of art science, which is extremely interesting to consider when we discuss artistic expression in the ISS. So in July, I will present the second part of this talk with art for the ISS, artistic expression in the ISS, but also the ISS for art, like ISS for science. And we'll try to answer the usual questions, the what, the who, the how, the why, and the whom or for whom. Thank you very much.
Thanks a lot. Thank you very much for this presentation. Thanks to you three for these 3 presentations, very different and very complete. Thank you a lot. You can write down your questions in the chat, if any, and we are going to answer them. So we have a few questions for each point. I'm going to start with a question for Jason Aspiotis. So about on-orbit manufacturing, so space to space, wouldn't you need to already have a lot of raw material and resources up there? Is the idea to make parts that are too big to fit in? Okay, sorry. Is the idea to make parts that are too big to fit under rocket fairing?
That's a good question. So I see it in 2 phases. The first phase is, because don't forget, it's not about the size alone. It's also about the structural considerations. When you build things on the ground to go to space, the biggest structural consideration is going through that launch. That presents some very interesting dynamics to the structure that you're trying to launch, and a lot of the design goes into mitigating against that. So if you take that out of the equation and think about launching just raw materials from the ground, not only can you build bigger structures, but you don't have to worry about those structures surviving that very impactful event of the launch. So that's phase 1, just launching raw materials and potentially 3D printing large structures that A, can't fit because of the fairing, and B, don't need the impediment of the structural design that's limited by launch loads. And the next phase, to your first question, yeah, I mean, eventually, once ISRU becomes a normal part of the space ecosystem and you're sourcing materials from the moon, silica, other metals, then yeah, it will make a lot of sense to use those materials to build things in orbit, cislunar, and of course on the moon surface.
Thank you very much. Thank you very much for your answer. Next question for Lucy. Do you think that you will find some gender-specific differences in the immunodisease experience?
It's a very interesting question. The problem that we have right now, it's one of the limits, is the fact that there is a very small number of astronauts. And in order to draw conclusion in human physiology, you need to repeat your experiment on a large sample, a large cohort of patient, or of, I don't know how to call them, it's not really patient, but of subjects. And there is two biases when it comes to space physiology. The first one is that you have only a subset of the population as your subject to investigate, because it's most of them people between 35 and 60. General, they have a good fitness, they are in good shape. They don't have what we call comorbidity, so meaning several diseases such as diabetes and so on. And the other problem is that they are mostly male. And if you want to draw some conclusion, you need to have you need to have a large cohort with male, female, old, young people, or you need to start with some specific cohort and then to enlarge your study to a larger cohort. I don't know if I'm clear. It's complicated for me to explain in English. Anyhow, when they have done this immunostudy, I'm not 100% sure, but I'm quite certain that they exclude female on this first basis, on the first subject trial, because with 10 to 12 subjects is not much. It costs a lot to perform research in space, and especially when you have a human involved, because as we know, human crew time is one of the most expensive thing in space. So I'm pretty sure, I haven't seen in the literature any difference between female and male in terms of immunology, because I believe that it has not been constructed to address this specific point when they developed the study. So my answer is, we don't know. Was it was too long and too complicated to explain that, but basically we don't know.
Okay, thank you very much for your answer.
Sorry for that. I was like in discussion.
You can still ask questions in the chat if you have in mind. Now a question for Annick. Do you think there would be more opportunities in the future for art in the space field? And what do you think about the place that has the artistic expression in current space missions?
Well, there is a lot of projects currently being done, but not necessarily being done in space. Done, for instance, with satellite data, with a lot of information that the space sector is currently producing, and there is really a lot of things. There are a lot of projects that have been done in parabolic flight. And so far, the artists have had, let's say, a reasonable access to parabolic flight. In space, in the ISS, or on other planets, it's of course much more complicated. And from my point of view, it could be really further increased without necessarily being super expensive or super complicated or dangerous for the rest of the team and the equipment. But it's a growing field. It's really a growing field.
Okay, great. And I have a last question, but for everyone. So we will start with Jason, then Lucy, then Annick, if you want. From your point of view, what is the more sustainable business workflow to do research in the future in space, using public-private space station, private-public single satellites?
I think it depends on the research, and I believe it's a hybrid model, because there's always going to be fundamental research that either the results or the implications are not clear enough in terms of private funds to take the risk to go fund it. At the same time, there's going to be applied research that even though it's risky, there's a conceivable path of, here's what I'm trying to figure out, here's the product it leads to, and here's the market ends up being, in which case private funding could very, very well fund that, even though it's still risky. So I think the answer is it depends on the research and the ultimate outcome. But I think it's always going to be hybrid. Even with commercial space stations, there'll be public funding that will be used to facilitate fundamental R&D on commercial space stations. So I hope that answers your question.
Thank you. Lucy, if you may add something.
Yeah, I think it really depends what kind of research we are talking about, because I think I understand in the question that the difference between satellite and space station is basically the fact that we have human. So if you perform research that requires human, either as operator or as subject, at one point you have to have a spacecraft-like infrastructure. If you do, for example, automated research on lab on chip, or on even on a rodent for the BIOS mission from the Russian, you can do that on the unmanned capsule or satellite. So it's complicated to answer. And for the private and public question, I am in line with what Jason said. I think it will be for long still a hybrid model. We expect to have this commercial ecosystem to develop, and that the public institution will become one of many customers to a private service provider. But I believe that there is still activity as on Earth as for terrestrial aspects that are, especially for low TRL, and not super mature research, it has to be supported by public funding in order to decrease the risk for private entity. So I believe it will be similar as on Earth, where at the beginning it's mostly public funding, and when you advance towards market case, the private will take the lead. But that's a guess.
Okay, thank you very much. Anik, if you want to answer the question too.
Yeah, I think for me this is a very difficult question, but I think that maybe it could be space could be a way to redefine our vision of human activities and global activities, because obviously, and there are ethical issues here too. Obviously, when you put something, especially in low Earth orbit, to whom belong the low Earth orbit? We are talking about the entire planet. At the time when we discuss a global pandemic and we discuss climate change and major climate crisis, is it a good idea to go into a very strong commercial drive, or could we go to something which is more collective? And in any case, when something goes wrong, everybody has to come together to solve the issues. And when I will go to try somewhere into a more global collective system. So, and you know, when you send a robot on Mars and you want to get the pictures in the 5 minutes, well, the 8 next minutes to show the world, your pictures are shared or downloaded through everybody else satellites that are around Mars. So I have some kind of ethical issues with going, you know, commercial as we do on Earth. We have to reinvent what commercial means in this respect.
Okay, Thank you very much for these diverse answers, these different answers. We have a last question to everyone too. So regarding safety aspects, how do you manage the future increase of private space stations and thus astronauts in orbit with the huge increase in the total number of satellites and debris? So it's a very technical question too. Jason, if you have a word.
Yeah, it's definitely a concern. You know, the ISS has already had a few close calls with space debris, and there's not much you can do about it other than sort of predict it's coming and then try to change your station's trajectory to avoid it. So I think the best course of action for the ecosystem in general, and I'm going to reflect a little bit on Anik's philosophy on collectivism. I think space debris management remediation is a classic case of something we need to take care of as a whole ecosystem, and where public and private entities need to work together to come up with a good solution to stop it from happening. That's the first phase. Second phase, start cleaning up the mess. And then third phase is never do it again. But yeah, it's a real issue. And with these mega constellations going up in Leo, space stations in Leo are going to become interesting to manage, maintain, and operate from a space debris problem. So a bit of a non-answer, but you know, it's a big problem, and I think the industry and the whole world needs to worry about it and come up with some good solutions.
Thank you very much. Do you have an answer for this question, Lucy?
Not really.
Yes.
Not really. It is a huge concern, as pollution is a huge concern on Earth. Problem is, I talked with one of the startups that we are working with. They were looking for new customer, and I found a company working on the space debris removal. Say maybe it could be one of your customers, and they had a very, how to say, terrible word saying there is no economic model for debris removal. Meaning, and here it's support what I just said before. At one point, we need also our as an ecosystem, but also our public institution to take the lead and to pave the way, you know, to take care of this problem. And this is happening. There is lots of space debris groups in the UN, UNUSA, don't know how to say in English, in the space agency. And so another idea, it's of course to evangelize, to do the promotion, to explain basically what's a good practice for new space companies that are launching satellite constellations, that are launching hardware in space. Basically, we could have some regulations, some guidelines, some good practice to explain, to discuss, to make them aware. We have seen that in another topic at the French Space Agency right now. When we are developing a project, you know, in space you have phase 0, phase 1, 2, 3, basically when you advance in terms of hardware. We now are obliged to add eco-conception / climate change impact / sustainability in all our formal review, and we have to justify that we are doing something in terms of ecological impact while manufacturing new satellites. And it's brand new. It has been implemented in the French Space Agency, I think 2 years ago. It covers all the logistics, but also, for example, the mission and travel from the personnel, because we have lots of multicultural projects, so you have to do meetings everywhere. And it's not much, but we see this kind of initiative that are increasing. And I believe that for space debris, maybe there will be the same path, that if you educate the space student or the students that are going to work in the space business, if you educate project manager like me, when I started, there was not this sustainability paragraph section. It was just not even a question. I never asked myself, you know, are my projects providing pollution or impacting climate or so on? It was just not in our mind. So I do believe that space debris and also all these ecological questions will become more and more a collective topic. And public institutions should pave the way for that and implement good practice on their own supply chain and activity.
Okay, thank you very much for this complete answer. Do you have a word to add, Annick, on this question?
No, I think what Lucy just said is very important, that I'm dreaming of a real future for human in space. And if we want to achieve it, we have to take all this into account, or we will all be dead before. And well, it's a metaphor, but I think space can really be a model for us all to try to find ways. But I don't have any answer.
Okay, this is an answer. Thank you. Thank you very much. Thank you very much for your attention. See you for our last webinar on June 24th about moon activities. So also a very interesting topic. And see you on July the 3rd for the one that will be participating to the roundtable with Annick, who will be here. Thanks a lot for your attention, and thanks a lot for the presentation.